Welcome back to Auth Explained, Episode 2. Today we're tackling a protocol you've almost certainly used today without realizing it. OAuth 2.0, better known as the machinery behind every login with Google button. Over the next few minutes, we'll unpack how apps can act on your behalf, reading your calendar, printing your photos, posting on your timeline, without ever seeing your password. So let's start with the problem OAuth was invented to fix. Picture a photo printing app that needs your Google Photos. The naive solution, hand over your Google password. Suddenly, this little app can read your email, your docs, everything beside. You can't scope it down, you can't revoke it, and the moment you rotate your password, it all falls apart. What we really want is limited, revocable access to one slice of your data without the app ever learning your credentials. That's the question OAuth 2.0 was built to answer. So here's the one-sentence definition worth memorizing. OAuth 2.0 is a delegated authorization protocol. You're handing an app a narrow, well-defined permission to act on your behalf, not the keys to your account. 3 properties fall out of that. The app never touches your password. It only gets the specific scopes you approve, and you can pull the plug whenever you want. Keep those 3 in mind. The rest of this series is really just mechanics. Before we go further, let's clear up the single most common source of confusion in this whole space. Authentication is about who you are, proving your identity, basically logging in. Authorization is about what you're allowed to do once someone or some app is in the door. OAuth 2.0 lives firmly on the authorization side. If you want the identity piece, that's OpenID Connect, and we'll get to it in the next episode. So here's the mental model I want you to hold on to. A valet key. Some cars ship with one. It starts the engine and opens the driver's door, but it won't pop the glove box or the trunk. You hand it to the valet so they can park the car without handing over your whole life. OAuth does the same thing for your accounts. Your password stays yours. The app gets an access token scoped to just what it needs, and you can take that key back whenever you want. To make that valet key idea concrete, OAuth puts 4 players on the field. You're the resource owner. The data is yours. The client is the app asking for access, like our photo printing app. The authorization server, think Google or GitHub, is the one that actually checks your consent and hands out tokens. And the resource server is where your data lives, the API that decides whether the token you present is good enough to let you in. With those 4 players in place, let's watch them actually pass the ball. When you click Login with Google, the app redirects you over to Google along with the scopes it's asking for. You sign in, approve the request, and Google sends a short-lived code back to the app. The app then quietly trades that code, plus its own secret for an access token, and uses the token to call the API. Notice what never showed up in that exchange: your password. And the reason for the 2-step dance, code first, then token, is to keep the token itself out of the browser's URL, where it could leak. Here's that same handoff as a picture. You start on the left, get redirected to the app, which sends you to Google for the login and consent step. Google hands back a code, the app swaps it for a token, and from then on, the API trusts that token, scoped to exactly what you approved, on every single call. And that phrase, a scope to what you approved, is worth slowing down on. Scopes are how permission gets sliced thin. Profile just reads basic info. Email just sees your address. Photos, read-only, can look but never edit. And drive.file only touches files the app itself creates. So our photo printing app should ask for photos, read-only, and stop there. That's least privilege. Request the smallest set you genuinely need and nothing more. Now, OAuth doesn't ship just one flow. It ships a small family of them because a browser app, a backend service, and a smart TV all have very different constraints. Authorization code with PKCE is the standard path for web and mobile, the one our photo printing app would use. Client credentials is for service-to-service calls where no human is involved. Device code handles TVs and consoles with no real keyboard, and refresh token is the quiet workhorse that gets you a fresh access token without making the user sign in again. Let's zoom in on that first flow, because PKCE, pronounced Pixie, is what makes it safe to run on a phone or in a browser. The problem is simple. A mobile app or single-page app can't really hide a client's secret because anyone can crack it open and read the code. So instead, the app makes up a fresh secret each time. It hashes that secret into a challenge, sends the challenge along with the initial request, and then later, when it trades the authorization code for a token, it reveals the original verifier as proof that it's the same app that started the conversation. Now, there's a point of confusion worth clearing up before we go further. OAuth 2.0 is about authorization. It answers, can this app touch my data? But it deliberately doesn't tell the app who you are. That job belongs to OpenID Connect, a thin identity layer sitting on top of OAuth that adds an ID token. When you click Login with Google, that's actually OIDC doing the work. We'll unpack it properly in the next episode. Speaking of confusion, let's clear out a few myths that come up constantly. No, OAuth doesn't log you in on its own. That's OIDC's job, as we just saw. No, the app never sees your password. You type it on the provider's site, and the app walks away with a scope token instead. And no, Auth 2.0 isn't just version 1.0 with a fresh coat of paint. It's a different, simpler design, and the two aren't compatible. With the myths out of the way, let's talk about doing this well in practice. Stick to the authorization code flow with PKCE, ask only for the scopes you actually need, and validate redirect URIs strictly so nobody can bounce your callback somewhere nasty. On the avoid side, the old implicit flow is deprecated. Overbroad scopes are a liability, and client secrets simply don't belong in a mobile app or a single-page app where anyone can read them. Now, you're not going to build all of this from scratch, and you shouldn't. On the provider side, Auth0 gives you a managed platform, Okta covers the enterprise side of things, and Keycloak is the go-to if you want to self-host. Google and GitHub are where most of those familiar social logins come from. And on the developer side, libraries like Authlib for Python or Passport for Node handle the protocol details, while OAuth.tools is handy when you need to peek inside a flow and see what's actually happening. So let's pull the threads together. OAuth 2.0 is about delegated authorization, not logging in. Apps get a scoped token, never your password. There are 4 roles to keep straight: the owner, the client, the auth server, and the resource server. The authorization code flow with PKCE is the modern default you should reach for. And when you actually do need login on top of all this, that's OpenID Connect, which is exactly where we're heading next. But before we get to OIDC, a quick gut check. When is OAuth actually the right tool? It shines whenever a third party enters the picture, letting users connect an external account, accessing an API on someone's behalf, service-to-service calls, or our photo printing scenario where you really don't want to hold another site's password. On the flip side, if it's just a simple internal login or one app talking to its own database, you're adding ceremony you don't need. And if the question is purely who is this user, that's a job for OIDC, which is up next. If this episode sparked more questions than it answered, good, that means it's working. The Auth Explained series digs into the neighbors of OAuth, JWTs, OpenID Connect, sessions and cookies, and API gateways, so you can see how the whole picture fits together. And remember, OAuth only protects who can act on your data. The servers handing out those tokens need to be locked down too. If that side interests you, the SSH Hardening Mastery course over at Dargslan.com is a solid next stop. Here's a fun one to leave you with. That Login with Google button you've clicked 1,000 times, it isn't actually OAuth doing the login. It's OpenID Connect, a thin identity layer built on top of OAuth 2.0. OAuth grants access to your data. OpenID Connect tells the app who you are, easy to conflate but worth keeping straight, and a perfect topic for the next episode. And that's OAuth 2.0, delegated, limited, revocable access without the app ever touching your password. If the photo printing app finally makes sense, stick around. OpenID Connect is up next in the Auth Explained series. Hit subscribe and find the rest over at Dargslan.com. Thanks for watching.